momentum, or you can call it moment of momentum. And if I'm saying momentum simply, it means linear momentum. I'm saying here linear momentum. Okay, in the same way, if we are denoting the angular momentum by this letter L, small l, the moment of momentum will be R cross P. As the moment of force was R cross F, the moment of momentum will be R cross P. You can say its SI unit and its dimension. Do it by yourself. What will be dimensional formula for L? Now, this will be R P sine theta and n cap, let's say, with subscript L. You can again proceed in the same way. It may be R sine theta, that is perpendicular distance between momentum and the origin or point of reference, times magnitude of this linear momentum and this one. Or you can write it R, as it is written already, P sine theta, which is perpendicular component. Perpendicular means it is perpendicular to this R vector, position vector R. So you can write it R perpendicular, as we have done it already in case of torque. The same way we are following here. So you can write angular momentum equals to this thing, or you can write angular momentum equals to this thing or this thing. So if this angular momentum is analogous to linear momentum in case of rotational motion, the torque should be related to the same way as the linear momentum is related to the force. That is, time derivative of this angular momentum should be related to torque. Just do what will be dl by dt. So dl, we can write it r cross p dt. Now we can write here dr by dt cross p plus r cross dt by dt. If you don't know this thing, you have to understand a little bit of calculus here. So this is what we have to do. First, we have to take first function derivative here. If two functions are multiplied and then multiplied with second function, and then we have to multiply it with first function and derivative of this second function. So this is what I have done here. Okay, so this will be dr by dt will be velocity vector and cross momentum, and then plus r cross, this is force, linear, in case of linear motion. So we have arrived at the same scenario. This is moment of force or torque, and this is going to be zero. Why I'm saying this is going to be zero? Because v cross mv, or you can write m v cross v, and we know this thing is zero, v cross v. So ultimately, time derivative of this thing is torque.